Alrighty. Oh, wow. We have so many people here today. We got 3 people here. Wow, this is going to be a fun class. That means more time with Mr. Who. Who doesn't love that? Wow. I feel so flattered having 3 people here. Regardless of how many people we have, we are going to get started with today because physics does not wait for anybody. So we're going to get started. In the Zoom, hopefully you all had a nice Thanksgiving break. I certainly had a very uneventful break, so that was pretty good. But we're going to take a look at our first warm-up problem for today. So this is actually, there's a whole category of videos like these that are actually really funny. I'll play this one in a second. But for now, there is a, so if there's one problem here, we have a Lamborghini. I believe that's a Lamborghini, I think. And it's racing a farm truck in this video. So in the chat, I want you to answer which car do you think is faster and how would you measure the speed of either car? So again, we got 2 cars here that are racing. We got a Lambo, and then we have a farm truck. Which car do you think is faster and how would you measure the speed of either car? Again, so for today, we've got a Lamborghini that is racing a farm truck. Um, so in the Zoom chat, I want you to answer which car do you think is faster, and then how would you measure the speed of either car? Um, there's a whole category of these videos which are really fun to watch. But it's very fun to watch. But we'll see it in a second. But we'll take another couple of minutes. We got a couple people for pro Lambo. We got one person pro truck. Who got some good ideas on how you might measure speed. But let's see if we can get a little bit more opinions here. Oh, we got 3 people on the team Lambo here. We got 1 person on the team truck. Do we have any more opinions here? Any more opinions on which car is going to win? Again, put your answers in the Zoom chat here. Which car do you think is going to win? A Lambo versus a farm truck? And then how would you measure the speed of either car? But 3 people on Team Lambo here, 1 person on Team Truck. I won't reveal who's faster until we get a few more people. The farm truck tilt different. That's funny. Let's. So is that a pro farm? Does that mean okay? I think we're at 3 and 2 right now. 3 people pro Lambo, 2 people pro truck. Come on, let's get a few more people here. Let's get a few more. It's not interesting if we only have 5 people here who are. Okay, we got 4 people pro Lambo, 2 people pro truck. Let's shoot for at least 10 opinions here, right? It's not interesting if we only have 6 people who have opinions on a Lambo versus a truck. Let's get a few more here. Lambo or truck? Lambo or truck? Grace, are you Lambo or are you truck? Are you Lambo or are you truck? Are you truck, Grace? Okay, so say okay. Let's get a few more opinions in here. Few more opinions. All right. Okay, we got another person. Rebecca's on Team Lambo here. That's 5 Lambos, 2 truck. So, okay. So let's see. We will. Okay, got Lambo. Okay, so can we get 1 or 2 more people? 1 or 2 more opinions. Is the Lamborghini faster or is a farm truck faster? Can we get a couple more opinions in here, please? Please. All right. All right, that's fine. That's fine. We'll take a look here. All right, we got a Lambo pulling up here. So that was thing. The lesson I think you should take away from this video is if you spend 28 bucks on a farm truck, it'll race faster than a Lambo. So make sure you spend your money wisely. Don't buy nice cars when you can buy a farm truck. That'll destroy every other car. Okay, so wow, that was so interesting. I thought that was fun. There's a whole category of these videos, by the way, on YouTube, where it's just like these supercars. I think Top Gear, I think, did a video on this where they compared all these like supercars to like modded farm trucks, and the farm trucks like all win. Like they're just like absolutely absurd how fast they are. So, anyways, we're gonna talk a little bit today. We're gonna talk about this concept of speed because we are on the topic of speed. So, okay, so in the on Canvas there is a assignment called the velocity and speed notes. I'm going to link it in the chat here. So fill this out while we go along, and then you should be able to submit it this time on Canvas. So just fill that out, and while we're going through our introduction to speed and velocity, and then here's also a link to the slides as well. So take a moment to open this up, and then you can take notes along as we're going along this, and then submit it whenever you're done. So that's what I'm making today. In terms of due dates, so the end of the semester is coming up, so you should submit all of your assignments before the end of the semester. I guess that should be obvious, but a reminder, submit your before the end of the semester. And then if you have any questions about missing assignments, or what you're missing, or what you should do, or how you do grade-wise, you can just reach out to me, and I'll be happy to answer them as well. Yeah, so take notes on the velocity and speed, and then we will get started with our introduction to what speed is. Okay, so um, so let's talk a little bit about this truck versus Lambo. So the truck absolutely wrecked the Lambo, absolutely destroyed the Lambo. And that's because it covered the same distance in a much less time, right? They were both racing from the beginning, the starting cones, the ending cones. And so the truck covered the same distance in much less time, right? And so that's why, so we can say that when something covers the same amount of distance in a lot less time, right? We can just say that it was faster than the other car. So in other words, right, speed just measures how fast an object is moving, which I think is something that you're pretty familiar with, right? If something is really fast, right, we would say that has a lot of speed. If something is really slow, I would say it doesn't have as much speed. So when we measure the speed of an object, what we're really doing is we're looking at measuring how much distance it can cover in a certain amount of time, right? So for example, and we'll take a look at some examples in a second, but we're looking at basically how much distance it can cover in a certain amount of time. Faster objects cover more distance over time, and then slower objects cover less distance over time. And in terms of how you would calculate speed, you calculate speed by just taking your speed is equal to distance over time. So you just take the total amount of distance you have, and then you just divide it by the total time it takes, and then you'll figure out how fast something travels, right? So let's talk a little bit about some examples of speed. So I think you're pretty much familiar with the speedometer on your car, your family's car, your friend's car, if you play video games, the speedometer. So the speedometer of your car, right? It tells you it's called a speedometer because it's a meter that measures the speed of your car. Um, so if you read a speedometer and it says you're driving 60 miles an hour, what that tells you is that in 1 hour you can drive 60 miles, right? If your speedometer is saying 70 miles per hour, that means in 1 hour you can drive 70 miles. Um, right, that speed, that 60 mph, the miles per hour, right? That's a measurement of your distance, 60 miles over your time, which is 1 hour. Another example of this is, well, in physics we use meters per second. We don't really use miles per hour, we use meters per second. So if you're running at 5 meters per second, what this means is that you can every 1 second you can cover another 5 meters. So in 2 seconds you can run 10 meters. In 3 seconds you can run 15 meters, right? Just every second you can run an additional 5 meters. A important nuance is that speed can only be positive. It doesn't really make sense to have a negative speed. So let's say you're backing up in your car. So this is something I actually encourage you to, well, probably maybe not so much when you're the one driving, but if your family's driving, I would take a look at the speedometer on the car. So when your car is backing up, right, your speedometer is still turning to the right, right? Because there's no negative speed section. The lowest it goes is 0. Because the speedometer does not, right, it's always positive. There's no such thing as a negative speed. It doesn't like, I really don't know what it means to ride negative 5 miles an hour, because that just doesn't really make sense, right? If an object is just moving fast or it's not fast. And that's just because we don't really care about the distance. We don't care about direction. We only care about distance, right? So if an object is moving right, an object is moving left, we don't care. The only thing that matters about speed is just how fast it's going, right? Speed only cares about about the distance you're going, not the direction. And then there's just no such thing as negative speed, because speed can only be positive. It just doesn't really make sense to have a negative speed. Okay, so let's do a little quick check your understanding problem here. So we got our boy Khalid here. So Khalid is on a trip with his girlfriend, and he just wants to make sure that they're starting off right. He really just wants to talk, and he wants to figure out where they're going before they get lost, right? Um, so what happens is Khalid and his girlfriend, they travel 200 meters in 40 seconds before Khalid apologizes for going too far. So let's figure out what is Khalid's average speed. What is his average speed? So, Khalid and his girlfriend, they traveled 200 meters in 40 seconds. So what was their average speed? So if you're unsure what to do here, just remind yourself of what the formula for speed is, right? Speed is measuring your distance and dividing it by your time. So how much distance do we have? How much time do we have? What would the average speed be? We'll take another minute or so, a couple minutes for people to try to figure this out. Okay, so in order to figure out speed, you need to remember that speed is our distance divided by time. So our distance in this problem here, they travel a total of 200 meters, and they traveled 200 meters over a course of 40 seconds. So if we take our distance and we divide it by time, we get 200 divided by 40. 200 divided by 40 is 5. So their average speed was 5 meters per second. Hopefully that was fairly straightforward, nothing crazy here. Again, to figure out your speed, you just take your distance and then you divide by time. So I think speed is a concept that we're all pretty familiar with, something we've all used and seen on a daily basis. The next concept is a little bit trickier. It's pretty similar to speed, but it's a little bit trickier, a little bit more complicated. And so I encourage all of you to see if you can follow along here with our next idea. So we talked earlier, one of the things we learned earlier, maybe a couple weeks ago, was this idea of distance and disfooting, right? Distance is just how much distance you're covering in total. And then displacement is just, how much your position is changing. And the two are sort of two different things. So just like those two have a relationship, speed has another relationship with another concept, what we call velocity, which you might have also have heard of. We definitely used velocity in this class a little bit when we were calculating energy. And so we're going to talk a little bit about what velocity means. The velocity, more specifically, is the speed you're traveling in a certain direction. So when we say cat is moving at 600 meters per second, we are specifying the cat's speed, right? The cat is just moving 600 meters per second, specifying the cat's speed. However, when we say the cat is falling downwards, the Empire State Building at 600 let's just say meters per second, we are actually specifying the cat's velocity, and that's because the cat is traveling at a certain speed, which is measured in meters per second, and it's traveling in a downwards direction. So very important here, velocity has both a speed and a direction, like velocity has a magnitude and a direction, it's a vector. So velocity is the speed you're traveling in a certain direction. Both are important, right? If you just have speed, well, you just have speed. And if you just have a direction, you don't have velocity either. You need to have both you need to have both the speed and a direction. And then I would say don't worry about cats because cats have 9 lives and cats they're very good at falling. Yeah, what I've seen. So I think I know it's a little, yeah, the cats can be fun. 600 meters per second is pretty fast, though. Not gonna lie. I think that's like 1,200 miles an hour. Anyways, uh, so okay, let's continue on with velocity. Again, remember that velocity is the speed you're traveling in a certain direction. So let's look at what velocity means. So velocity, what it also sort of means is basically how fast your position is increasing or decreasing, right? If your position is increasing or decreasing, right, it means that there is a change in position. And when your position is changing, it means that you have some sort of displacement, right? So when you have some sort of displacement over some sort of amount of time, you're going to have a velocity. So velocity, in other words, is just the total amount of displacement you have divided by the total amount of time you have. This is a very important distinction that I want you to understand now rather than later. Speed is your total distance divided by time. Velocity is your displacement divided by time. And the two can be very different and very easy to mix up. Speed, we only care about the total distance you go. Right, left, right, left, right, left, we don't care. Velocity, we only care about where you started off and where you ended. That's the only thing we care about. Because it's related to displacement. That's a very important thing to remember. Velocity is displacement over time. And so because velocity measures how much your position is increasing or not increasing or increasing, it's increasing or decreasing. Because of this, velocity can be positive or negative, right? Unlike speed, if your velocity is positive, it means your position is increasing. But if your velocity is decreasing, right, it means that if your velocity is negative, it means your position is decreasing. So what does it mean if your position is decreasing or increasing? So, right, if you think about it on a number line, or on a graph, we have positive, we have negative. Right? If we're working on the x-axis, we have the positive x and we have negative x. So when you have a positive velocity, it means that you're moving to the right, your x is increasing. And then when your negative velocity is negative, you're moving to the left, means your x is decreasing. So this is sort of this. I think it's actually kind of. I think it actually should. I think if anything, it's probably be a little bit easier to tackle than displacement here. X is just basically velocity is basically which direction you're going, right? You're going positive or going negative. Does anyone have any questions about velocity or speed so far? Anyone have anything you want me to answer? Any particular thing on the note sheet that you want me to go over? All right. Okay. So, um, so we're gonna do a little TBT back in the day. So TBT back in the day, back when Mr. Who was in high school, which is a long time ago, I needed someone to go to prom with. So the problem was back in the day, instead of asking someone in person, we used Craigslist. So I go on Craigslist and I type in nearest human. Please go to prom with me. The problem was the nearest human was a kilometer, 1,000 meters east on Craigslist. East is to the right. So I'm like, okay, I'm gonna go just find this person on Craigslist. So I run 1,000 meters east in 10 seconds. So run 1,000 meters to the right in 10 seconds. I reach the human, and then I figure out that I actually got catfished, and then the human wasn't real. So very unfortunate for me. So then what happens is, in order to take out my anger, I run 2,000 meters west, and I did that in 10 seconds, and then I go yell at some kids to get off my lawn, because that's what I do. So we're going to try to figure out what is Mr. Who's average velocity in this journey. So we'll take a couple minutes to try to figure this out, and then I'll do it on the board here. So this problem can be kind of tricky. The first thing you want to identify is basically first of all, how much total time per throughout the journey, and then see if you can identify how much my total displacement was, because average velocity relates to displacement and not to distance. So we'll take a few minutes to work through this, and then we will figure out what was my average velocity during this very traumatic time of my life. So one thing we want to keep in mind here is that velocity is a little bit tricky because velocity also has a direction, right? Speed doesn't have a direction. If you're going 60 miles an hour, you're going 60 miles an hour. But for velocity, right, we want to have a direction. Because right, are we going west, are we going east, are we going north, are we going south, are we going left, are we going right? Velocity needs to have some sort of direction. Uh, Oh, we actually have actually no. We have a very good point here that I do like. So, um, actually, here's what I'll do right now. For those of you still working on it, you can take a stab at it. I will actually try to explain a very important nuance that a couple people have out that I will actually go through right now. Okay, so there is actually huge. So actually, I really love how we do this. Okay, there are two sections, right? You first go 1,000 meters to the left, and then you go 2,000 meters to the west. So plus 1,000, and then this will actually be negative 2,000. Right, so you first go positive 1,000 because you're going to the right or east. And then here you're going negative 2,000, or you're going west. We're going left. So right here, let's actually break this up into two sections. Let's call this right and left. So when we first go to the right, we're starting at a position called the 0. And then we're going 1,000 meters to the right. So we start at 0, and then we end positive 1,000, right? We go 1,000 to the right. So our displacement is the change between our position. So we start at 0 and we ended at 1,000. The displacement is positive 1,000 meters. So we can then figure out our velocity for this section. So our velocity is our displacement over time. So our velocity here would be 1,000 over 20 seconds. And then this would just be v is equal to 50 meters per second. Right. Or you can just write it as positive 50. Okay, so I actually did not intend for this to be a two-section problem, but this is what's what we're looking at. So each one of these particular sections, going right and going left, they each have their own individual velocities, and then there is a whole average velocity. And I think that's something that I forgot to include here, which is actually very important. I'm glad you noticed it. So what we're doing here is we're just looking at the velocity for the initial section where you went right. Now we're going to take a look at the velocity going to the left. So we're going to do this exact same thing here. Where are we starting? Well, this time instead of starting from 0, we're actually starting from positive 1,000 meters, right? And then we are then going to go 2,000 meters left. So we're actually going to end at negative 1,000 meters. So our displacement is the difference between our ending and our beginning. So if we started at negative 1,000, if we started at 1,000 and we went to negative 1,000, our displacement here is negative 2,000. Okay, because we went 2,000 in the negative direction. And then so our velocity is our displacement over time. So that means our velocity is equal to 2,000. Oh, sorry. The first one this occurred over 10 seconds. Each section occurred over 10 seconds. So this should actually be 100. And then this also occurred over 10 seconds. So velocity is 200 meters per second left. And the better way of doing this is just say negative 200 meters per second. Because the negative tells me that you're going left, which is very important. Okay, so now what we have here is we have a velocity for each section. Basically, because how fast I'm going to the right is different than how fast I was going to the left. And so each one of these sections has a different velocity. And so when you're dealing with, different paths, like different
paths of travel. Each path is going to have a different velocity. When I did this problem, I did not mean for it to be, I did not mean for you to try to figure out each velocity individually, but this is a very important nuance here. So each velocity, each particular section has its own velocity. So now we can take a look at the average velocity. So when the average velocity here, what does it mean is we're looking at our overall displacement over our overall time. So each one of these measures our velocity in a particular section, right? Our average velocity measures our velocity as a whole. In other words, where were we in the very beginning and where are we at the very end? We don't actually care what happened in between for average velocity. We only care about the very beginning and then the very end. So what I'm going to do here is I'm going to write down where are we in the very beginning. In the very beginning, we are at 0, right? Because we started from 0. And then where are we at the very end? The very end, we are at negative 1,000 meters, right? Notice how I don't actually care what happened here. I could have went here, I could have went there, I could have went there. I don't really care. The only thing that matters is where are we at the very end. So at the very beginning, our very end is 0. Our very end is negative 1,000. So let's call this one. I'm going to call this our total displacement. In other words, what is our total displacement from the beginning to the end? So our total displacement here is negative 1,000. Because we went from 0 to negative 1,000. So if you notice, our total displacement is a little different than the displacements of these sections, right? The displacement of these sections is basically measured for each section, how far does it go to the right, to the left. Our total displacement just measures where are we in the very beginning and then where are we at the very end. Okay, so to figure out our average velocity, very important. What we're going to do is we're going to take our total displacement and then we're going to divide it by our total time. So our total displacement is negative 1,000. Total time is 20 seconds. So our average velocity was negative 50 meters per second.
What would the purpose of doing the like T-chart with left and right be if you can do very beginning and very end?
So good question, actually a good question. So it depends what the problem is asking for. So if I ask you for the average velocity for the whole trip, you only need to do the beginning and the end, right? The whole trip, right? So, however, if I ask you, hey, what is my velocity for when I'm going east, then you would need to actually figure this part out. And if I say, hey, what was my velocity going west or going left, you need to figure this out. So it depends what the problem is asking for, and that's very important when we're looking at this. So if I say, it depends on if I'm looking for a particular section or if I'm looking for a whole. When I use the words average velocity, this is very important. When I use the word average velocity, I generally mean the velocity for the whole thing. But this can be a little tricky too. I can say what was my average velocity for when I was going right, in which case you would do this. I can see what was my average velocity for when I'm going left, say this. And then if I say what my average velocity as a whole for the whole trip, then you would say this. If you're ever confused about what I'm asking for, just let me know and I'll try to make it more clear. But when I see average velocity, I'll usually mean the whole thing. Another reason why this is important, you may not need to do this for when you're figuring out your average velocity, but it's important to know how fast you're going in any particular segments, because we're going to do a little bit later today. We're going to do some graphing, where we're going to graph our velocities. And when you're graphing your velocities, you're not going to be graphing your average velocity just a straight line, because you're not moving at this velocity the whole time. This is an average, because you're moving at this in the beginning, and then you're moving at this at the end. So you're not actually, traveling at negative 50 meters per second the whole time, right? You're traveling at 100, and then you're going traveling at negative 200. So when we're graphing it, it's very important to graph your velocities for each section. You're not graphing your average velocity as a whole. Okay, so while we're on the topic of this, I thought, here's what I'm thinking. I think it actually might be good for us to take a look at other things too. I, I haven't quite talked about this yet, but here's what I'll do, take a look at. So our velocity and our speed are sort of related, right? Our velocity is our speed in the direction. So let's say I said, hey, let's figure out our speed for each section. So if we want to figure out the speed for each section, right, we would do something similar. But instead of having a negative displacement, we would have a positive displacement here, positive distance. Sorry, excuse me. The speed is your distance over time. So when I'm asking you to figure out your speed, you're usually taking a look at the distance traveled for each section. Right? So if you notice for any particular section, not the whole thing, every particular section where you're going in one direction, your speed is just basically the absolute value of your velocity. So the absolute value of something just means that it's always the positive version of this. So our speed here for when we're going right, is just 100 meters per second, right? Because you're traveling 100 meters per second going right. And then our speed to the left is the absolute value. In other words, the positive version of this. That means our speed here is 200 meters per second. And this is for any particular section. The reason why I say any particular section is because when you take a look at this average speed for the trip as a whole, it's not going to be so the speed for any particular section is just the absolute value of the velocity, right? The average speed for this whole section is not just the absolute value of negative. And that's because your total speed, your average speed, relates to your total distance over your total time. So I'm running out of space here. Okay, so let's take a look at our average speed here. So our average speed is similar to how our average velocity was our total displacement for our total time. Our average speed is going to be our total distance over our total time. And our total distance was, we went 1,000 to the right, and then we went 2,000 to the left. So our total distance is 3,000, not negative 1,000, because this is distance. Distance, we don't care about direction, we only care about how far we went. So our total distance is actually 3,000, our total time is 20, and so our average speed is actually 150 meters per second. Notice how this is different than this, right? They are not the same thing. When you calculate your average speed, you actually have to figure out your total distance and your total time for your average velocity, your total displacement over your total time. But for any particular section where you're just going in one direction, the speed is just the absolute value of this. And actually, that's true for your displacement. So this can get kind of tricky, but hopefully I did a reasonable job of explaining it. I think it'll be a little bit easier to see once we get them up practice, sort of see it a little bit more visually. But I do like how you were noticing how there are different sort of velocities for each section. Unfortunately, I don't have a section on this for your notes, but I would try to include a section on it. We're sort of talking about how there are sort of velocities for sections, and then there's your velocity for all. Does anyone have any questions about that? I don't want to rush those because I know this is tricky. Okay, so I'll leave this up, but I'm just going to switch our views over just to moving on to the next part. But I'll show that again later on. So let's talk a little bit about again about velocity here. I think this example here just sort of shows how to figure out your average velocity over the whole section. So this is here is sort of how we did it previously.
If we want to figure our average velocity, we would take our total displacement, which is we started from 0, we ended at -1,000. Our total displacement is -1,000. This occurred over 20 seconds, so our average velocity was -15 meters per second. When we do our total distance, right, we want 1,000 to the right, and then we want 2,000 back to the left. So our total distance is 3,000, which is a little tricky, so very, very important. And then we take our total time, which is 20 seconds. So when we figure out our average speed, we take our total distance, 3,000, divided by 20, and then we get 150 meters per second. And again, just notice how velocity can be positive and negative. And just remember that velocities need to have a direction, which is either positive or negative. It helps me if you just, even if it's positive for velocity, it helps me if you just write a plus sign before. So then I know that hey, you know that it's a positive velocity. Because I want us to get us in the habit of remembering that velocity has a direction. So it's very important to show that you know that velocity has a direction. Okay. So another little check your understanding thing. So in your own words, I think I'll have a space in there, but I want you to write this down because in your own words, I want you to write down what the difference between speed and velocity is. This is very important because something I've really realized is, and it's sort of easy to understand or remember what I told you. But I think sometimes if I tell you something, it doesn't really make as much sense if you have your own definition for it. So I want you to write something in your own words, right? Feel free to be as colloquial, use as much slang as you want to see if you can write down what you think is the difference between speed and velocity in a way that makes sense to you. So that if I said, hey, what do you think is the difference between speed and velocity? You can explain to me what you think it means. So I want you to take a few minutes to write down your own definition between the difference between speed and velocity. See if you can notice the difference. If you're still unsure, just let me know and I can try to explain it a little bit more as well. Try to write that out. And then whenever you're done with one, when you're done writing your own definition, the difference between the two, I want you to answer this question. So the speedometer of Owen Wilson's car. So Owen Wilson and Keanu Reeves are both featured in the Academy Award-winning film Bill and Ted's Excellent Adventure. And so Owen Wilson plays, who is Bill? Is Bill Owen Wilson? I don't remember. But Owen Wilson's car is driving northwards at 400 kilometers an hour. Keanu Reeves' car is traveling southwards at 400 kilometers an hour. So I just want to think about, do both cars have the same speed and do they have the same velocity? So you can answer question 2 in the chat whenever you're ready. But question 1, you can just do on your own. And then we'll take a few minutes to do this.
Should we put it in the chat or just write it down?
Put question 2 in the chat. Question 1, write it down for yourself. Question 2, put it in the chat. So I'll take another minute or so. If you need more time, just let me know. I'll take another minute or so, and then we'll move on to the next sort of example problem. Okay, so we'll move on to, oh yes, so let me answer question two first. So they both have the same speed because Keanu Reeves and Owen Wilson are both driving at 400 meters per second. They do not have the same velocity because one of them is going north and the other one is going south. So that is an important distinction. You can have the same speed but have different velocities. You're going to different directions. Okay, so we're going to move on to another check your understanding question. So this one is going to feature me and my friend Paul Pierce. So one day I decided I'm going to start growing taller. I go 7 inches taller and I gain 60-pound muscle. Actually, 60-pound muscle might not even be enough. Anyways, because I'm way more athletic than I used to be, I say, hey, I don't want to teach an NBA anymore. I'm going to play in the NBA, and then I get signed by the Boston Celtics. So in the 2008 NBA Finals, Paul Pierce has a knee injury. So this is actually true. Paul Pierce has a knee injury, quote unquote knee injury. And then so that is true. This one probably maybe not as much. So after Paul Pierce has this quote unquote knee injury, I played 30 seconds in game one before Paul Pierce miraculously comes back in to ice the game. Legend has it that Paul Pierce faked an injury so he could go to the back. I think he actually might have confirmed this, but I'm not actually sure. Anyways, so the key piece of information is that I played for 30 seconds in game one of the NBA Finals. Definitely a true story. So during my 30 seconds of playing time, I did absolutely nothing because I just ran in a circle. So what I first do is I first run 4 meters east, I then run 2 meters south, I then run 4 meters west, and then I run 2 meters north. So I want you to answer these questions. What is the total distance I traveled? What is my total displacement? What was my average speed? And then what was my average velocity? And I think here's what I'll do. I'll actually put you into your breakout room so that way you can talk a little bit and then see if we can work through this together. And then I'll bring this back in a few minutes once everyone is sort of ready. So see, work into a breakout room, say hi, check in with everyone, and then see if you can answer these 4 questions. So hopefully y'all get a chance to chat with each other a little bit. I'm trying to wrap up. I'm gonna try to cover as much as I can in the last 10 minutes of class here. What was the total distance I traveled for this? So if I traveled 4 meters east, 2 meters south, 4 meters west, 2 meters north, I'm traveled 4 plus 2 plus 4 plus 2, which is 12. So I travel a total of 12 meters. What is my total displacement? Well, I start in the top left corner, right? I go left, I go right, I go down, I go left, I go right up again. So I start and end in the exact same location. Very important. Because if I start and end at the exact same location, my total displacement is 0. Very important. Displacement, again, is the difference between your starting and your ending location. So if I start and end in the exact same location, my total displacement is 0. What was my average speed? My average speed was, ooh, that's weird. My average speed should actually be 12 divided by 30, which is a 0.4. So what is my average speed? So my average speed is my total distance, which is 12, divided by my total time, which is 30 seconds. So 12 divided by 30 is 0.4 meters per second. I believe, yeah. And what was my average velocity? My average velocity is my total displacement, which is 0, divided by time, which is 30 seconds. 0 divided by 30 is 0. So my average velocity is 0 meters per second. Again, this is different than my average speed, which can be a little bit tricky. Okay. So let's talk a little bit about what it means to have a constant speed and velocity. I think this is something that I might have introduced a little bit before, but I want to sort of go over. So when something has a constant speed or a constant velocity, so something with a constant speed means your speed is not changing. So something with a constant speed, it doesn't speed up, it doesn't slow down. So it's like putting your car in cruise control. And it's just going the exact same speed the whole time. It never speeds up or slows down. Constant velocity means you have to have both a constant speed and a constant direction. So what constant direction means is that your direction never changes. So you have to drive in a straight line. So constant velocity, in other words, it means you have to drive in a straight line at a constant speed. Very important. Constant speed just means your speed isn't changing. You can turn all you want as long as you're not speeding up or slowing down. Constant velocity means you have to drive in a straight line and you can't speed up or slow down. So teachers and donuts. So if my car is doing donuts at a constant speed in a circle, is the car driving at a constant velocity? So it's not driving at a constant velocity because even though I'm driving at the same speed, my car is turning every second, right? I have to actually physically turn my steering wheel in order to hold it at a constant, in order to go through the circle, right? So in other words, if you have to touch your steering wheel, your car is not driving at a constant velocity. Okay, so we won't quite get into, we'll talk more about graphs on Thursday. I'll start introducing parts of it, but we'll do some of the meatier parts of the graphs on Thursday. So I'm just going to quickly introduce some key ideas about graphs. So we've done a little bit of number lines and stuff. We've done a little bit of, I think in the City 2D one, we did a little bit of graphs there. We're going to be doing a lot more graphs for distance, displacement, velocity, and speed. So key idea is that the slope at any point, any distance versus time graph. So first off, I should say this first. So first off, we can plot distance as a graph versus with respect to time, right? So you would put distance on the y-axis, you put time on the x-axis, and then so your distance versus time is going to be like a graph, right? So every second, you're going to show how far, where your car is, how far it's driven. The slope at this of a distance versus time graph is the speed at that point. Oh, hold on. Hold on. I wasn't even sharing my screen. That's not good, not ideal. So the slope of a distance versus time graph is the speed at that point. Right, the slope of distance versus time is speed. Very important, the two. It's a very important relationship, right? If slope is basically measuring how much something changes every second. And so speed is just basically how much your distance is changing every second. So the slope of a distance versus time graph is the speed. Also important is a displacement versus time graph. The displacement versus time graph is different than a distance versus time graph because the displacement versus time tracks your position over time, right? You can have a positive position or a negative position. Or the distance versus time graph, you can only have a positive distance, and your distance can only ever increase, right? The total amount of distance you travel can only ever stay the same or increase. The displacement, right? Your displacement can change all over the place. So you can go right, you can go left. And the slope of a displacement versus time graph is the velocity. Slope of distance versus time is speed. Slope of displacement versus time is velocity. When you look at a displacement versus time graph, if you want to figure out the speed, you can just take the absolute value of the velocity at any point, right? Because your speed can only be positive. So if you have a negative slope, you can just take the absolute value of it, and that'll be the speed of it. And the thing with this, the way how slope works is, the steeper your slope is, the faster your speed is, right? Because that means you're traveling more distance every second. So we have we'll do this next part on Thursday, but I'm just going to show you what a displacement versus time graph sort of looks like. So for a displacement versus time graph, what I have here is I'm mapping out my displacement. In other words, how my position relative to a starting point 0 as a function of time. So here what I have is I'm showing my displacement. I'm showing that it is changing. It's going up, it's going down, and it stays the same, right? And so this is all compared to time. So your displacement is on your y-axis, and then your time is on your x-axis. And then a distance versus time graph would be something similar, but instead of displacement, maybe distance. And remember, your distance can only ever go up. There are two other types of, well, there are other kinds of graphs that are also important that I don't have a visual for it yet. We'll do again, I'll do on Thursday. There's also a velocity versus time graph, and that measures how fast you're going at any particular point in time. So right now, for this unit, very important as well, we are working with a constant velocity. In other words, within any particular section, your velocity is staying the same. Very careful, be very careful with my words. Within any particular section, my velocity is the same. So you know how the problem we did previously, where I went right and then I went left? My velocity changed, but that was between sections. Within the section, it's always staying the same velocity. And then you can assume that it switches instantly between sections. We'll do something called acceleration, where you're dealing with changing velocities, and that'll happen next semester. But right now, everything that happens is within a particular section, portion of a problem or a graph, your velocity is constant. Okay. So, does anyone have any last minute questions for me before I wrap up? I know we covered a lot of things today.
Could you go back to the last few bullet points on the page where you did the, what was it? Constant speed and constant velocity. Thank you.
So something with a constant speed, it doesn't. So something with constant speed doesn't speed up, or doesn't slow down. So something with constant speed doesn't speed up or doesn't slow down. Something with constant velocity means it has both constant speed and it has constant direction. Constant direction means this constant direction is in a straight line. So that means constant velocity just means you have motion in a straight line at a constant speed. And then last but not least, my Prius is not driving at a constant, is not driving at a constant velocity because I'm going in a circle And then when I'm going in a circle, I have to turn the steering wheel, which means that my direction is changing every second. And that can also be tricky as well.
Thank you.
Okay, so out of time here. So we're not going to have any homework, and then we'll pick up where we left off on Thursday. Again, if you have any assignments or any things that are missing or any revisions, just keep submitting those, and I will be grading stuff throughout this week. I didn't really do much grading over the break, but I will be doing quite a bit of grading this week. Other than that, you're free to go. If you have office hours from 2:40 to 3:40 today, if you want to say hi or have any questions. If you have any questions about your grades or anything, assignments you should do or whatever, you can stay for a few minutes after class and I'll try to answer any questions you have, just because I didn't get a chance to answer everyone's questions. But other than that, you're all free